Good afternoon. This is Rich Nass, and I am here for this week's installment of 5 Minutes With. This week we have the pleasure of speaking with Scott Hanson, who is the CTO and the Vice President of Engineering for Ambiq Micro. Hello, Scott. How are you?
I'm good. How are you?
Just fine, thank you. Thank you very much. Okay, so Ambiq is a fairly new company as far as I'm aware, and you guys have a pretty interesting technology that's a little more complicated than it's fairly complicated, but I was hoping you could explain it to me in terms that I could understand. And what I'm referring to is your Subthreshold Power Optimized Technology, otherwise known as SPOT.
Yes. Yeah. So, subthreshold operation is it's a technology that's been around for 30 or 40 years in a very limited way, and Ambiq is the first company to really go out there and propagate it everywhere in the system. So what we do with our circuits is actually operate at very, very low voltages. Now, in a conventional circuit, you signal a 0 with a 0 volts. You signal a 1 with a much higher voltage, something, let's say, typically on the order of 1.2 volts. So this has the effect of giving us a very weak 0 at 0 volts and then a very strong 1 at 1.2 volts. And it's very easy to differentiate between the two. So the problem is that energy goes quadratically with voltage. So by swinging to such a high voltage, that 1.2 volts, I'm spending a lot of energy. In subthreshold operation, we limit that voltage swing. We signal a 0 with a 0, but we signal a 1 with a much lower voltage on the order of 0.4 volts, 0.5 volts, 0.6 volts. In fact, it's called subthreshold because we never actually let the voltage go above what's called the threshold voltage of the transistor. So we're never actually turning the transistor on. The net result is that we get tremendous energy savings that go quadratically with voltage, and that equates to incredible battery life, great new features, a variety of other things that our customers do. So viewed another way, what we actually do is just modulate the leakage current in the chip and use that to run our computations.
Okay, well, that certainly explains it. Thank you very much for that description. Okay, so with the power levels that we're talking about now, I'm assuming that this opens up applications aside from just being able to use a smaller battery or being able to go longer on a charge. What sort of revolutionary things are you enabling?
You know, what's probably most exciting with a lot of our customers is some of the new cool features that they can add to a device that was previously dumb or relatively simplistic. So today we're shipping into a variety of smart credit cards with our first product, and today a smart credit card is something that looks more or less like every other credit card. It has a magnetic stripe and maybe an RFID or an NFC chip built into it. With us, you can actually take power down so low that you can put a paper-thin battery inside of the credit card. You can put a display in there, keep track of time, and do a variety of interesting things that enhance the security of the card. So suddenly your credit card, instead of being a cheap piece of plastic with a magnetic stripe, is like a little computer. The problem there, of course, is that you've got a tiny little battery, no charge, and so the electronics need to be as energy efficient as possible. That's where we come in. We're also seeing our customers build. So the obvious question there, is somebody developing a battery like that one? Yes. So these batteries exist. We have a variety of customers that are building exactly this product, and I think many of us will start to see them out in the field and in use very shortly. So, very exciting technology. We've got a variety of other customers. Go ahead.
I was just saying, I read somewhere that you developed this with the University of Michigan. I was wondering what role they played.
Well, so actually, I came originally from the University of Michigan. I was a researcher there. I worked with my two co-founders, Dennis Sylvester and David Blau, who are professors. We all co-developed the technology along with a number of PhD students, and then spun it out in the form of Ambiq Micro. We were at the university studying ultra-small, ultra-low power electronics for medical and defense industries. That evolved into some incredibly low power subthreshold electronics and ultimately led us to spin this company out and go after this new exciting Internet of Things.
So is the university still in the picture, or are they no longer involved?
The university, besides being a stakeholder in the company, has continued to be engaged, and in particular, I'm engaged with my two co-founders. We continue to brainstorm on new concepts. We have pulled additional new technologies from the university as they've developed them, and probably the most exciting opportunity is to pull out new, exciting students that are graduating from these various groups. So we're always looking for ways to recruit people from there. But in the meantime, we're maintaining a very tight relationship with my two co-founders who are professors there.
Excellent. That's great to hear. I love to hear that. When you're having fun, time goes fast, and our 5 minutes is up, I am afraid. That was
thank you for your
5
time.
Minutes with. Oh, my pleasure. Thank you. That was this week's installment of 5 Minutes with, and that was Scott Hanson of Ambiq Micro, and this was Rich Nass of Open Systems Media. Thank you very much.